Hello everyone. Today is July 4th, Saturday, 2026, and I am your host, Sana Annie. Ready to bring you another super exciting radio show? And today, I'm introducing a really trending article from the archive. And it is packed with mind-blowing technology. The title is, Towards Memory-Efficient Autoregressive Video Generation via Instance Specific Parametric Absorption. The title is, So Colin //cargtheff.org/abs/2607.00712v1. Huh? It is a bit long, but I promise the contents is absolutely fascinating. Anu, let us dive right into the core of what this paper is all about. Have you ever tried using one of those cool AI video generators? They're super fun, but generating really long videos, or doing it in real time, is incredibly difficult for computers right now. To understand why, we have to look at how these AI models actually work. Most modern video generators use something called autoregressive streaming, which means they generate the video frame by frame, just like drawing an animation one picture at a time. But to make sure the video makes sense, and that the characters do not randomly change their clothes or faces, it has to remember all the past frames it just drew. It stores these memories in a place called the key value cache, which is basically a temporary memory bank. That is right. As the video gets longer, this memory bank gets fuller and fuller. Eventually, it completely overloads the computer graphics card, and the whole process slows down to a crawl. It loses the magic of being real-time. No. The common way engineers try to fix this in text-based AI, like those chatbots is simply by dropping or deleting old arrays from the cache. But if you do that with video, it is a total disaster. Dropping those tokens breaks the long-range dependencies, which means the AI basically gets amnesia. The background starts flickering wildly. The characters lose their identity. And the whole video just turns into a wobbly, distorted mess. So, what is the brilliant solution proposed in this paper? The researchers introduced a totally novel framework called Instance Specific Parametric Absorption, or ISPA for short. Instead of just throwing away those precious historical memories, they figured out a way to distill them and absorb them directly into the actual brain of the AI model. Yes, they absorb the history into the model weights themselves. Let me explain how this works in a bit more detail. Because it is super clever, the AI model has many layers, like a huge delicious cake. Normally, all these layers are full attention layers, meaning they look at the entire huge memory cache. ISPA changes a subset of these layers into local attention layers, which only look at the very recent frames, to make sure nothing is forgotten. ISPA uses a brief warm-up phase at the start of the video. During this warm-up, it watches how the full attention layers behave and compares them to how the local attention layers behave. Then, using some really elegant math, specifically a closed-form least squares problem, it calculates a special weight adjustment, and this adjustment artificially injects the missing historical context right into the parameters of the local attention layers. That means these layers do not need the heavy memory cache anymore, because the memory has been permanently baked into their connections. It is like studying for a test so well that you do not need to bring your messy notebook into the exam, because the knowledge is already absorbed into your head. Let us compare this with other technologies, because that really highlights how amazing this is. Traditional methods just prune the tokens, acting like a bouncer kicking memories out of a club. But as we said, that ruins video quality. Other methods try to compress the video offline, which takes massive supercomputers and tens of tons. ISPA works completely on the fly, during the standard forward pass of the model, without requiring heavy gradient optimization, uses a clever down-compressible attention mechanism, which basically means it can track both full and local attention at the same time. using almost zero extra computing power. That is right. They tested this on massive models up to 14 billion parameters and found it can remove up to 50% of the memory cache with near lossless visual quality. When combined with special quantization techniques, even makes the video generation almost twice as fast. Now, let us talk about how this incredible technology can be applied to our everyday lives. I have 3 super specific application examples for you. They are all so exciting. First, let us think about real-time virtual streaming, like VTubers or digital avatars. I'm right now running a highly realistic, AI-driven avatar. Requires thousands of dollars in high-end computer gear. Mostly because of that memory overload problem. With ISPA, the AI can continuously generate the avatar speech and facial movements, hour after hour, without the memory exploding. The paper even tests this on a speech-to-video model called Live Avatar, but perfectly maintained the speaker identity and lip sync, while drastically cutting down the memory cost. This means everyday creators could run Hollywood-quality avatars right from their standard gaming laptops. Second, imagine endless, personalized AI movies generated on the fly. Maybe you want to sit back and tell the television to generate a brand new, infinite sci-fi adventure, starring a character you just invented. Currently, AI can only make videos that are a few seconds long. Before the computer runs out of breath, because ISPA absorbs the long-term memory into the model waits, the television would never forget what the main character looks like. Even an hour into the movie, the background would stay consistent. The story would flow beautifully, and the television would not crash from memory overload. It basically unlocks the dirt in our very own living rooms. Third, this technology is going to completely revolutionize the video game industry. That is right. Imagine a game where the environment is not pre-built by developers, but is actually hallucinated by an AI in real time, reacting to your every move. To make a game world feel real, the game engine has to remember the layout of the town you just walked through. Normally, an AI would choke trying to render a continuous 30-minute walk through a dynamic world. But by using Instance Specific Parametric Absorption, the game could smoothly transition its rendering layers, locking the memory of the town into the local weights. You could turn around, and the buildings would still look exactly the same, without any of that weird AI flickering. It makes real-time, infinitely generated game worlds truly possible, bringing unprecedented immersion to gamers everywhere. This research is just so inspiring, because it completely rethinks how we handle artificial memory. Instead of treating memory like a physical object, you just throw in a digital box. It treats like an experience that the AI can learn and internalize on the spot. I really hope this perspective encourages even more future work, exploring how we can consolidate memory in streaming generative models. It is a huge step forward for AI, and I cannot wait to see all the creative ways people use it. Well, that is all the time we have for today. I hope you enjoyed diving deep into this fascinating paper with me. Technology is advancing so fast, and it is always a blast exploring it together. Thank you so much for tuning in, and I will catch you all in the next episode. Stay bubbly, stay curious, and have a wonderful weekend.